See, this summer vacations, I am going to tell you a lot of things, certainly related to your syllabus and a lot of things out of your syllabus, but certainly they'll interest you. First of all, I am starting with something like in coordinate geometry, it's got something called a point. So, see this dot, we call this dot as a point, okay? Now, suppose I call this point as A, and then I can have any other point B over here. If I join these 2 points, it is always a straight line, okay? And we call this line as AB. Fine. Now see, these are 2 points A and B, and they are joined by a line called AB. Now a third point C, it can be anywhere. We can have a point over here, a point over here, or a point on the line. Okay. So supposing the third point is over here. So now if I join these 3 points, what do you get? We call this as a triangle. Triangle. Okay. Tri here means 3. Okay. And angles means these angles. What the lines make with each other. Okay. So I'll be starting with these very small basics things with you first of all. So okay, see, I've got here 3 strips with me. Okay. I've got 3 strips with me over here. And now I'll show you what is a triangle. See, if we join these 3 together, this is called a triangle. Okay. So you see this triangle? Now the triangle can be in different ways. Even see, this is a triangle. 3 sides and these are called the angles. Okay. So this 3 sides and 3 angles. So this forms a triangle. You can also have a triangle like this. Okay. These 3 lines may join in different ways. The length may be different and the angles may be different. Okay. So this is, what do we call it? This is called as a triangle because it always has 3 sides and 3 angles in it. Okay. Now these triangles are of different types. Like supposing if I say that one of the angle is of 90 degrees. This becomes a right angle triangle. Okay. In right angle triangle also, like see, the other 2 sides may be of different length. Again right angle, this length and this length is different. See, another right angle triangle, but the lengths are different. Okay. These are all right angle triangles. Another way, I can have a triangle like this. This is a special case. In this, all the 3 sides are equal. Okay. And as such, all the 3 angles will also be equal. So this becomes a special case. We call it as an equilateral triangle. Equi means equal. Okay. What do we call it? The second one, if you draw a triangle like this, in which all these 3 sides are equal and all these 3 angles are also equal, we call it as an equi. Equi comes from the word equal. Equilateral from the word straight. Equilateral, and triangle I'll write like this for short. Okay. If suppose I got a triangle like this, wherein this angle is 90 degrees, we call it as a right angle triangle. Okay. Right, because it's 90, we always consider as right. See, I'll show you one more instrument. The importance of 90 degrees. See this. I don't know whether you would have seen it or not. This is used by all the carpenters. They use something like this. The masons, the one who make the buildings, they use something like this. This is fixed. This angle is always 90. Okay. This angle in between. So they use it for construction. Like suppose if I want to put this cable, I want it at 90 degrees. So we use something like this. 90 degrees. This I wanted at 90 degrees. This is how they do. So this 90 degrees got so significance. Okay. So this is right angle triangle. Then the other one is equilateral triangle. Okay. So you see this. Now suppose if we have to join 4 points together, what do we get? Suppose if I've got 4 points here, A, B, C and D. A, B, C and D. Achha, remember one thing, see, I'm always writing the points in a particular way. What we use here is that it should be either clockwise, that means the way the clock goes, or anti-clockwise, in the direction opposite to the clock. So it becomes easier. So I've written A, B, C and D. Suppose I join them together. So what do we get now? We get something that is called as a quadrilateral. Quad means 4. Quadri, again lateral word comes. Okay. So quadrilateral means 4 sides. So with four sides, you can have different kind of figures. Like you can have something like which we call as a square. What is a square? It is a quadrilateral because it has four sides, and additionally all the four sides are equal. Okay, so that's a quadrilateral. But another one, that's a square. Another one with four sides can also be something like this. This is a rhombus. आप लोगों ने वो खाया होगा, काजू बर्फी खाई होगी. They are made in this form. It's rhombus. Again, the sides here are all same. Okay, but the angles are not equal. In this case, the opposite angles are equal. This will be equal to this, and this angle will be equal to this one. So it becomes a rhombus. Okay. Then we've got something called as a rectangle. In a rectangle, see, these sides are same and these two sides are different. This side is equal to this side. This side is equal to this side. Then we've got something as a parallelogram, something like this. Again, opposite sides are equal, but in this case, the angle is not 90 degrees. That means this angle is not equal to this angle. This angle will be equal to this angle, just like the rhombus, and this angle will be equal to this angle. Okay? So this becomes what we call it as a parallelogram. So these are basically some very basic geometrical figures. First, a point is there. 2 points joined together to form a straight line. 3 points joined together may form a circle. Why may? Because see, the 3 points can also be something like this. Suppose you've got A, B and a third point C. It may come up on the same line. A special case can be like this. But otherwise, whenever 3 points join, they will form a triangle. Okay? Triangles, different types are there. Then 4 points form a quadrilateral. Okay? Then you've got square, rhombus, rectangle and parallelogram. Examples of your quadrilateral. Okay? So now I'll tell you another small question which comes up a lot of times. What do you mean by the word perimeter? Okay, you see this? The entire shaded area, this is basically a square. I'll show you how. You see this side? This is how much? 100 centimeters. 100 centimeters. 100 centimeters and your 100 centimeters. Okay. Now the question is, suppose I want to put a fence all around it. So how much of wire will be required? Okay, that is the question to me. So how do we do it? I'll show you. See, I got a piece of wire with me over here. Okay, let me just measure it out. I'll do it the crude way. I don't know any maths right now. I'll put this over here. I'll just try to tie this rope all around it. See, it's going round, and where is it finishing off? Just wait. Let us just check this out. Like this it goes, like this it goes, here it goes, and then it comes up to which point? The starting point. Okay, this is my starting point. Okay, so I'll just now remove this from here. This is it. So basically I require this length of rope. Okay, till this point. Let us just measure this out, how much this length is. So see my scale. I think I'll try with my scale first. See, my scale is not that length, so I'll use something else. I'll use this scale. I'll use this one. See, again the readings are the same, but see again it is 10, 20, 30, 1, 2, 3, 4. It's all the same, but the length is new. So I'll measure with this. I put this thing here. How much should it be? Let us just check this out. This is how much. This is around 400, right? 400. Why 400? Let us just check this thing out. I had told you earlier that in this figure, all the four sides were of 100, right? I had put my nail at this place and taken it around like this, the wire all through. Okay, so and my question is, how much wire was used? You checked it out, it was how much? 400 was the answer. How did we reach this figure 400? Let us do it with using maths. Okay, I started from here, I travel this place. I'll forget this part. You start from here, you travel here, this is 100. Add another 100 to it. Then add another 100 to it. Then you add another 100 to it. Okay. How much is it? It is 100 plus 100 plus 100 plus 100, 100 into 4. So this is how much? 400. Okay. So means either I do it, I actually physically put in the rope and then I start with all that measurements. Okay. Or I can do it like this. Now supposing I had to put this rope twice, 2 times. Okay. Like this once and then again one more time. So how much will it be? 800 if I do it twice. Okay. And here also I can just multiply it by 2, 800. Now how do we get this figure? So if we talk in mathematical terms, let us say this is length and this is, let us say, the breadth. Okay. So how much it is? It is 2 times length plus breadth. Or you can say it is 2 times 100 plus 100. Or it is how much? 2 times 200. Or it is how much? 400. Right? So this is basically we call a perimeter. Means when you start from one end and you reach the last end, just going around, it's a perimeter. Okay, we'll check it once again. We'll check it with this smaller part. Okay. This is basically a rectangle that I made. This side is again 10 and this side is 50 now. Okay. First let us check the answer. Okay. I got a rectangle now. This time I'll have a rectangle. This is 100. This is 50. So the answer should be 2 times, perimeter should be equal to 2 times length plus breadth. It should be equal to 2 times 100 plus 50 is equal to 2 multiplied by 150. So 15 2s are 30. So this should be 300. Okay. Something is missing over there. Is it okay? Okay, let's just check this out. See, I had some doubts in it, but my doubts are not well placed. So we'll just check it out over here. Okay, I'll put this thing here. I go round, I go round, I go here, and then I come back to this point. Which point? The point from where I had started. That is this point. Okay, let us just check this out. This point. Let us see how much is it now. 400, 300, 200, 100. How much is it? Let's check this out. So I put this here and you see this is all exactly 300. Okay, exactly 300, right? Or you measure, check with this also. You put it here, you just put it here and then you start measuring it out. Where do we reach? This is 2 and see, it's 300, right? It's almost 300. This wire is turning, so I'm not very, see. This is 300, isn't it? So in this case, the perimeter is 300, okay? Means if I start from this place, I go all the way around, round and round. How much distance I'll travel? 300. I started from this place, I went like this, like this, like this, like this, all around this thing, like this, like this, like this, like this, like this, like this, like this. And when I came back, it became 300, okay? So this is what this is called as a perimeter, right? So you can also try something like this in your houses whenever you want. What I've done is that first I made a square this size. I put in nails over here so that I could get the exact calculation using this wire. Okay. So, and this is basically how you make your gardens. Isn't the fencing done like this? They put in poles and then they put in fences, this string like this. So this is again maths. Even there, like supposing if you are to give an order to someone to put in a fencing, if you know maths, the other person will not be able to cheat you. Otherwise, let us say the distance is 300, he'll say, ma'am sahab, 600 meter hoga. You'll buy 600 meters of string for him, isn't it? So this is the use of maths over here. Okay, now I'll tell you one more example. Now this time, supposing I've got I got a circle now. What is a circle? I'll explain to you the circle. What do you mean by circle? See, in a circle, what is there? We have got one point here, okay? And keeping this as one of the point, if I make something like this, just a minute. This figure that you get, this is called as a circle. What is the benefit of what is the main thing here? All the points here, point A, point B, point C, point D, point E, any number, they're all at the same distance from this point. And that distance, how much? It is this distance. Okay, they're all at the same distance. And this distance is called as the radius here. Okay, this distance from this to this is called as the radius. And this is all the same. Okay, so now I'll tell you something more about perimeter. Perimeter is not something which is used only for figures like rectangle or triangle. I can also use it for something like this. This is basically, we call it as a disc. Okay, it is a circle and it's also got something like this, so it's called a disc. Okay, and what is the diameter of it, radius of it? See, this is almost, it is this much, right? So now I'll just measure it out. It is coming at almost 25. Okay, I'll just note down the radius of this is coming at 25 centimeters. Okay, we need to measure what? We need to measure the perimeter. What is perimeter here? Perimeter is nothing but this, starting from this point and going all the way back to the same point, which you also call as circumference in the case of a circle. I think circumference will be the word that you would have heard more. Okay, so what we do, I put my nail here and I take it around this body. You see, I just put my nail here and I'll, just a minute, wait, please. Just give me 1 second, I need to put it somewhere. Okay. I put my nail here and I've taken my string all around this. Okay, and I've reached back to the same point where I started. Okay, so what is this called? This is the circumference, because you see, this wire is going all through it. See this wire, it is going all through. Okay, so this is the perimeter, or you can also call it the circumference. Let us measure this out, how much it is. So I put this point here. Let us see how much is it. It is coming as somewhere around 160. Am I right? Around 160. Okay, I just note this down. As per physical check, the perimeter, or you can also call it the circumference, is how much? It is around 160. Let us check this out mathematically. We know the radius here. I'll show you again. See the radius. This was the radius. I measured it with my scale. It was somewhere around 25. Okay. So my radius here is 25. So the circumference, you got a formula for that. That is called 2 into pi into r. That is called the circumference. This is 2 into pi is what? 3.14, and r here is 25. If you multiply them, it becomes 50 into 3.14, and this comes to, what I'll do is that, okay, let me do one thing. I'll do a trick here also for you. I'll make it 2 multiplied by 50 multiplied by 3.14 and divided by 2. Can I do it? I both multiplied and divided by 2. Okay, so this becomes 100 now into 3.14 divided by 2. So this becomes 314 divided by 2, isn't it? And this becomes how much? 2 ones are 2, 2 fives are 10, 14, 2 sevens are 14. So we get an answer of 157 here, and this is also almost same. It is 160. That difference, the maybe because of this measurement, number one, or it could also have been because of that wire that I used. But otherwise, you can see that this is the circumference, okay? If you start from one point and you go all across, you call it the circumference in the case of a circle. Or in other terms, and in other figures, you can call it the perimeter. I'll give you one more example here. Like you see this figure? This is basically how we have our fields, okay? Or any of the, so see here what will be the perimeter? I start from this place, I go like this, I go like this, I go like this, and I come back like this. That is the perimeter of this, okay? Now in this case, I would also like to tell you about one more thing, area I would like to explain, that's why I showed you this diagram. Supposing I want to cover this entire open space with something like this, okay? I want to place them like this. So I want to know how many of these will be required to completely fill this up. That is my question to you now, okay? Let us check this out. So perimeter, I think we are done with it. So again, coming back to the rectangle, this time I'm talking to you about area. Suppose if the length is L, the breadth is B, then the area becomes L multiplied by B. Okay, this is the area of this figure. So again, my question is, this is my one figure. I want to cover this entire open space with this. How much of such strips will be required? So let us just measure them out. How much is this? This is approximately 160. Okay. For the bigger one, there's no harm in drawing things like this here in maths. Okay. This is 160 and this one is how much? It's almost like 100. This is 100. Okay. So the area of this will be how much? It will be 160 multiplied by 100. Am I right? Now let us check the smaller one. What is the length? The length is around, I'll call it 90. For the smaller one, this strip, this length is 90. Okay. And how much is this? This is approximately your 20. Okay.
25.
Okay, I'll make it 25. So what is the area of this? 8. So when I measured this, one side was 25 and one was 90. So the area is what? 90 into 25. Now suppose we say that we have to have multiple x number of such strips are required. So I just said 90 multiplied by 25 multiplied by x will be equal to what? This much, the entire area. Okay, that is 160 into 100. So now you can solve it for x. 160 into 100 divided by 19 into 9. You can solve it and you will get the answer. Okay. Now I'll just like to give you another problem now. Okay, I just want to give you a problem because this solution I'm not giving, and I would like you to solve this problem out and come up with the answer to me either through mail or whatever means. I will just like you to solve a small problem for me, a very practical one. Okay, so I'll just give you the problem. The problem here is that there is a brick. Okay, you know brick with which we make houses. There's a brick. The size of the brick is 9 inches by 2.5 inches. Okay, now we have to make a big wall out of it. We have to make a wall. We make a wall like this. We have to make a wall here. Just give me a second. I'll draw the wall and then I'll ask you the question that is required from you. Okay, very practical because maths is all about what you see around, how you can simplify things. We got a wall here. This wall is basically, the height is 6 feet, okay, and the length is 10 feet. Okay, you have to make a wall. The height is 10 feet and the height is how much? 6 feet. Okay, one brick, this is a single brick. Okay, I know the size of a single brick. It's 9 inches by 2.5 inches. So now my question is, how many bricks will be required to make this wall? Okay, just for your help I can tell you, or I'll just say a little bit. See, the area required is how much? It is 10 multiplied by 6. So that is how much? 60. But it is in square feet. This is fit, this is fit. And the size of brick is how much? 9 multiplied by 2.5. This is how much? 9 5s are 45, 4 carry 5, 9 2s are 18, 18 and 4, 22. This is in square inches. Okay? Understand, see, in maths even the units are very important. This is in square feet, this is in square inches. Now you cannot compare oranges with mangoes. You cannot compare horses with donkeys. But you can always compare oranges with oranges and donkeys with donkeys. So the thing is, first you need to convert these units. So I'll tell you how it is done. We know that 1 feet is equal to how many? 12 inches. Okay. So 1 feet into 1 feet will be equal to how much? 12 inches into 12 inches. That is, it is equal to 144 square inch. Okay. So now you can certainly do. So the area required now will be how much? 60 multiplied by 144. See, this was square feet and this is square inches. So many square inches are required. Okay. And you know the size of a brick is how much? 22.5 square inches. So if you can divide this number by this number, you'll get the answer. Now this much I have done. Now I will not be spoon feeding you. I would like you to come up with an answer for this. Okay. And hope you enjoyed this session. And I hope to look forward to more such sessions with you. Okay. Enjoy your day. Bye. See you.